Alright, in this video lesson we're going to see how to determine the range of a rational function. Stay tuned, this is ASCII tutorial. We are going to have a beautiful time. Now let us see what the problem says. The problem says find the range of the function that's given as f of x equals to x over 1 plus x squared. In order to determine the range of a function, we have two methods. The first one is algebraical method and the second one is the graphical method. So the algebraical method is just by finding the domain of an inverse function, we can determine the range of the original function, and graphically just by sketching the graph of the given function we can easily get the range of the function from the graph. Now in this particular case we are going to apply the algebraical method of determining the range of the function. Now in order to find the range of the function algebraically, the first thing is we should have to find the inverse of the given function. So as to determine the inverse of the function, you know that f of x means y. Now to find the inverse of a function algebraically, we have to interchange x and y. Now interchanging x and y, we will have x equals y over 1 plus y squared. That is the first step. And secondly, let's apply crisscross multiplication and you will have x y squared plus x equals to y. Now let's transfer the right y to the left side. We will have xy squared minus y plus x equals to 0. Now this is a quadratic equation with variable y. Now to solve for y, let's apply the quadratic formula. The quadratic formula minus b means 1, plus or minus b squared is 1, minus 4 times ac, a is x, c is x, so ac is x squared, divided by 2y's of a, that is 2y's of a in this context is x, so 2y's of x. So this is the inverse function when it is expressed as the original f of x form. Now to find the domain of the inverse function, we should have to consider two cases from the given inverse function. Now before that, the inverse function, let's write down here the inverse function that we previously done. So the inverse function f inverse of x is already obtained to be 1 plus or minus radical of 1 minus 4x squared divided by 2y's of x. Now from this functional form we can clearly understand that 1 minus 4x squared is inside the radical, so it has to be greater than or equal to 0, and 2x is in the denominator, it has to be different from 0. So there are two considerations in determining the domain of the function. Now with the first consideration, 1 minus 4x squared can be written as 1 square 2y's of x, the whole everything square, radical greater than or equals to 0. Now let's factorize this one applying the difference of the square formula. So you will have 1 minus 2x multiplied by 1 plus 2x greater or equals to 0. Now, if you remember in our previous video lesson, how to determine quadratic inequalities using the zigzag line method, the zeros of the factorized form in an increasing order are -1/2 and 1/2. Now the leading coefficient is negative, as you can see. So our zigzag line will start from below the horizontal line, and our zigzag line will just like this. Now the inequality says greater than or equal to 0, so it's a region above the horizontal line that this region is located, and between -1/2 and 1/2, including -1/2 and 1/2. Now, but bear in mind that x has to be different from 0, and 0 is found in the middle of these two reference points, so we have to exclude 0. So in order to exclude 0, we have to use open interval from the left and from the right of 0. So the range of the original function, which is the ultimate objective that we are going to determine, is therefore equals to the domain of f inverse function, and which is from -1/2 up to 0 excluding 0, and union from 0 excluding 0 up to 1/2 including 1/2. So this is the range of the given function. So the answer for this case will be choice D. Thank you very much. Don't forget to subscribe.